Hello viewers, welcome back to another section of my multivariable calculus tutorials, and in this video we're going to solve a problem in triple integrals where we are going to express the limit as spherical coordinates. So let's move straight to what we have for this video. Evaluate the triple integral of x squared dv where our region E is inside both x squared plus y squared plus z squared equals 36 and z equals negative square root of 3x squared plus 3y squared. Now, to approach this problem, you just ask yourself, what do I need to solve this problem? How am I going to get my limit points? Now, to do that means you are supposed to sketch this region, and from the sketch you'll be able to know the various parameters we need for spherical coordinates. First of all, we need three parameters to compute this integral in the spherical coordinates. The first one is our phi, rho, and theta. These are the three important parameters we need after we have sketched this region. The question is, what is phi, what is rho, what is theta? Now let me start from rho. Rho is actually the radius of a sphere. Yes, the radius of a sphere. That is rho. Theta is the theta we know from polar and cylindrical coordinates. Theta is the angle our region is going to make with the xy plane. Then finally our phi is the angle this rho makes with the z-axis. So let's see. The next thing to do is to find the various limits for these stars. Then how do we do that? So first of all, the region is inside x squared plus y squared plus z squared equals 36. From quadratic surfaces, you realize that x squared plus y squared plus z squared is an equation for a sphere. So meaning this is written as x squared plus y squared plus z squared is equal to rho squared, where rho is the radius for our sphere. Then we can say rho squared is equal to 36. Therefore, our rho, the sphere, is going to give us 6. That is the square root of this. We are going to take the positive side because it's a distance. We are interested in the magnitude. So once you have rho, since it's a radius, it's going to start from 0 rho towards 6. Now we are done with our rho. Then the next thing is z is equal to negative square root of what? 3x squared plus what? 3y squared. From quadratic surfaces, this can be rewritten as z squared is equal to 3x squared plus 3y squared. And this is the equation of a cone. Kindly revisit quadratic surfaces to know the equations and their corresponding solid figures. This is the equation of a cone. Since it's negative, meaning it's going to lie, its axis will fall on the negative z-axis. But what will this equation do for us? This equation is going to be the actual figure. So the rho is not going to be a radius for a sphere, or we're going to consider the rho, the phi, that's the angle this rho is going to make with the z-axis. You realize that it's through this that you're going to get that particular angle. So let's make a quite simple sketch here. I'll have my z-axis going down, my x and my y. So therefore our cone, the tip will rest here, then the base will come here as a sphere, like this. So in a 3D, this is a cone with a sphere base. That is an ice cream shape. We call it ice cream shape. So with this, now we're going to find our phi. But one thing, when you are dealing with the cone, the phi is not so easy to find that of the sphere, where you just have 0 to pi or 0 to pi on 4. But here you need to solve it mathematically. So using the equation of the cone, we can find our phi. So let's see. Z in the spherical coordinate is given by phi or rho cos phi, right? This is equal to negative of the expression x squared plus y squared gives us r squared from the cylindrical coordinate. So this is going to give us 3r squared, right? When I simplify this, I'll get rho cos phi is equal to negative 3 root 3r. But this r is the same as rho sine phi in the spherical coordinates. Make sure you understand and you know how to convert from polar to cylindrical, then to Cartesian, as well as to spherical, how to go by the conversions. So here I finally have rho cos phi is equal to negative root 3 rho sine phi. So you realize that rho sine phi, when I divide through by rho cos phi, I'm going to get tan inverse, or tan phi is equal to 1 over root 3. I'll add my negative here. So my phi is actually equal to negative 30 degrees. Negative 30 degrees. So they are saying that the radius with which this rho will move to create this is equal to negative 30 degrees. We are not interested in degrees, and don't forget the rho or the phi is always between 0 towards pi. That's the maximum. We don't introduce negative phi here. So what are you going to do? You are going to find the equivalent of this within this interval. So realize that you add it to 180, that it is falling in the third quadrant. If I draw my quadrant, you realize that it will be positive here, then negative here. So the negative here, that is third quadrant, will help us get our what? Conical shape. So here you realize that you add 180 to it, right, to make it positive, and that is giving us 150 degrees. So tan of 150 will give us what? Negative 1 over root 3. You can test. So now you convert 150 towards pi radians. So we're going to get 150 over 180, and that is giving us 5.6. So phi is giving us 5.6 watts pi, right? So meaning the interval for pi is going to give us 0. Sorry, this is not from 0. Since it lies here, it's going to start from 5 on 6 pi, that is 150. Then you know less than or equal to what? Phi less than or equal to pi. So you can see that from 150 towards 180 gives us our what? Phi. So the phi is 30 degrees, yes, 30 in magnitude, but the direction here is negative. It's negative of z, the negative z direction. So it is going to span from 150 towards 180, giving us our 30 degrees. That is why we represent it in pi as this. Then finally, we need for theta. To get theta, you are going to make a projection of this on the xy plane. So on the xy plane, you realize that since it has a spherical base, it's going to collapse. When you collapse this from the base, it will give us a full circle on the xy plane. And the circle is telling us that the angle our phi is going to make from the base of this solid figure is going to make with the xy will be 2 pi, 0 to 2 pi, 360. It's going to form a 360 round. See something here. There is the outline for our sphere. And when you push or collapse this here, you realize that it's going to take this shape. So meaning it's going to turn itself round on the xy plane. Therefore, our theta is simply going to lie from 0 towards 2 pi, right? So now we are done with all our conversions. So we have to convert. The function is x squared. And you know that x in the spherical coordinate is given by what? Phi sine phi, then what? Cos what? Theta. So you bring your triple integral with our phi 5 on 6 pi, then another integral 0 to 2 pi, another integral 0 to 6 of this whole thing squared. Open brackets, rho sine phi cos theta all squared. Then we introduce our rho squared sine phi, the rho, the theta, the phi. This is our representation in the spherical coordinate. The rest is for us to compute, which is very simple. This will become rho squared sine squared phi, then what? Cos squared theta. Then it's multiplied by everything here, rho squared sine what? Sine phi. I can further simplify this rho to the power 4 sine cube phi cos squared theta, the rho, the theta, the what phi, right? Now I'm going to first integrate my rho because the inner integral I have. When I integrate this, I'm going to get rho to the power 5 over what? 5, right? Yes. Then when I get rho to the power 5 over 5, sine cube of phi cos squared theta, then I introduce 0 towards 6 here, then I bring my d theta, d phi, then my second 0 to 2 pi. So when I put this in, what am I getting? When you put 0 there, you are going to get 0, 6 to the power 5, 7, 6, all over what? 5 sine cube phi, then cos squared theta, like this. I introduce my what? Sorry. The next thing I'm going to do is I'm going to integrate with respect to theta. That will be my second. So the theta here, the phi. When I integrate this with respect to theta, there's the theta here as I have here. I have cos squared theta. So if you have cos squared theta, how are you going to simplify this? How are you going to simplify cos squared theta? Now I can show you this, how you're going to compute this on your calculator. So using the calculator, you can go by this simply. Using the calculator, you can easily go by this. So now, what you are going to do when you are dealing with triple integrals and you want to apply your calculator here. Okay, so what you are going to do is you are going to integrate this expression then with respect to theta. I have cos squared theta. If you want to go through the manual way, it's going to take very long. So let me teach you how to use a calculator to point this. So you just come here. You can realize that we need what? This one is a constant now. So we are going to put the constant somewhere, right? So you put this constant somewhere. Then the next thing you are going to do is you are going to focus on what you have here. You're going to focus, that is cos squared theta. So you go to integral. That is your 0 to 2 pi, we make it 0 to, let's say, 360s. Then you have the cos squared of what? Your x, alpha x, right? You close, then you press. So you see what you have. So now the answer we got is what? 180, right? Yes, so once you call 180, you realize that this one was in what? Degree. So you just divided by 180 to get in pi radians. So now what we are going to get is what? Pi. Our answer is obviously pi. So therefore you not undergo the stress and we quickly bring this one out here. So I'm going to get 5 on 6 pi towards pi for the inner, and I'm going to get my 7776 over 5. Then the solution that I got here from the calculator was what? 180, which is the same as pi. Then sine cube of what? 5, like this. So at this point again, the phi, we still apply the calculator. Then here our integral is from what? 150 to what? 180. Then our function here is what? Sine cube of what? 5. So we press sine to the power 3, sine to the power 3 of what? X. We don't use phi, we're going to use x as what we have here. So you use x like that, you close, then you press equal to, and let's see what you have. So don't forget, yes, the answer you are having here, once you've gotten it, you're going to find it equivalent in 180, then we add pi to it. So you are getting 0.98 then we're going to have our final solution to be 7776 all over 5 pi, then multiplying 0.982 this all over what? 180, right? So this is going to be a very small number, but we still can simplify, divided by 180, and we are going to get 7776 over 5 pi, then multiplying 5.458 times 10 to the power -3. So you can further simplify this down, or you can leave your answer this, which is also right. So there's a way to compute your triple integral with spherical conic. Thanks for watching, and don't forget to subscribe, like, and share.